Okay, our goal here is to replace this big long formula for the standard deviation of our portfolio with a matrix solution. And so let's look for the pattern, the rhyme behind the reason of this big long ugly formula. It's the square root of each stock times its standard deviation squared, plus 2 times the correlation between each pair of stocks times the weights and the standard deviation of those stocks. That's kind of ugly to say quickly. Let's look at it mathematically. So in the same way we use this mathematical notation to sum up the individual weights and returns of each stock, we can look at the risk of the portfolio by taking the square root of the variance of the portfolio, which is summing up over every combination of two pairs of stocks in our portfolio, those stocks' weights and those stocks' standard deviations, and the correlation between those two stocks. Let's see how that would look in a table form. If we wanted every possible combination of our three stocks, that makes 9 possible combinations of stocks. And if we take each one's weight and standard deviation and the correlation between the two, then these 9 possibilities are all of those combinations. And we're going to sum that over all 9 possible combinations. And if we add those all together, we get something that looks like this. This is just the result of each of the 9 boxes above added together. We can do some simplification on this. The most obvious is that the correlation of any stock with itself is 1. So let's remove those. And let's put all the terms that end up looking like squared terms together. Then let's put the terms that look like each other together. And now let's talk through this. We have Kellogg weight squared times sigma squared plus ExxonMobil weight squared times sigma squared plus Walmart weight squared times sigma squared. That's the first 3 terms in this big long equation. Next, we have the weights of ExxonMobil and Kellogg times each other, and the sigmas of ExxonMobil and Kellogg times each other, and the correlation between the two. The 4th and 5th lines here are really the same thing, so let's combine them. The same with the next 2 lines and the last 2 lines. And now we have exactly the equation shown in the spreadsheet. So we've used this mathematical notation to recreate the formula we've been using in the spreadsheet. And if we recognize that sigma times the correlation, and sometimes I've used R and sometimes I've used rho here, but sigma times the correlation between the two stocks is the covariance of those two stocks. So we could write this way. To implement this in Excel using matrices, we need to find something called a variance-covariance matrix. The variance-covariance matrix looks like this. It's the same thing we saw before without the weights. And we can simplify it as we did before. To look like this. So let's learn how to make this variance-covariance matrix in Excel. To do that, we need to calculate something called excess returns. An excess return is the return in any given period over and above the average return of all the periods for the stock. So if we take the average return for all the periods and say that in this period for Kellogg it was this much above or below the average, then we can copy that and see what the excess return was in every period for every stock. So when Exxon lost 31%, that was 35% below the average return when Kellogg did that. When Exxon gained 22%, that was 9% above the average return. So now we have an excess returns matrix. Our variance covariance matrix will be a 3 by 3 because we have 3 stocks. And we want to know what Kellogg, ExxonMobil, and Walmart look like in terms of variance covariance. The formula that we'll use to get the variance covariance matrix is itself a matrix formula. So we have to select all 9 cells that we want populated before we begin typing the formula, which is matrix multiply, the transpose of the excess returns, times the excess returns, and then we want to divide all that by the number of rows in the excess returns, the number of periods. So the easiest way to calculate that is there's a rows function, and we could point that at any single column in here, but we may as well point it at the entire excess returns matrix. It has the same number of rows as any of its columns do, and then we can have a nice clean reference that we use 3 times up here. Not very confusing. Control Shift Enter, and we get the variance covariance matrix. From that matrix we can calculate the risk of the portfolio in one cell. It's the matrix multiplication of an array which is itself the matrix multiplication of the weights, the variance covariance matrix, with the transpose of the weights. And then we'll Control Shift Enter to calculate that. That gives us actually the variance of the portfolio, and we want the standard deviation, so we'll take the square root of that. And again, to enter it, Control Shift Enter. And that standard deviation of the portfolio matches the standard deviation that we found with the same weights. So if we put the appropriate dollar signs on this, then we can copy it up and down the column. So let's enter it one more time up here. It's the square root of the matrix multiply of the weights with the variance covariance matrix, and we'll put dollar signs on that, with the transpose of the weights. Close out all of our parentheses and Control Shift Enter. And we get the same answer we had before, and each time we copy that down, let's make sure we get the same answer. So that was a fairly laborious run through how we started with a couple of stocks and built our way all the way out through multiple stocks using matrices to calculate standard deviation and return of a portfolio. The next video, let's take a simple review to see just the basic steps. First, let's get a clean sheet to work with and update our formula list. This layout should be a little bit easier for us to work with. Now let's update our formulas. Let's copy this tab and make a blank one to do a practice problem with.